All right. My point with this is this can be your small bit, and I'll have a big bit, but this is just your small bit of kinetic energy represented by a brick being thrown by a smaller person, and then you have a really big person uh, representing the bigger mass, the 2 bit, and he is throwing a cinder block. So my only, well, the only intuition I can gain is that yes, the big particle is going to collide with the small particle, and the big particle is going to gain the kinetic energy because it's just the bigger. It's just the source in terms of having an inverse of force, uh, having inverse force as kinetic energy, and it possibly being a representation of the three body problem with the sun. You could say, well, the sun and the earth, or the earth and the moon. Uh, Even in that sense, the small object could be the moon being thrown at a high speed into the earth, which was which has been being hurled around by the sun. I don't mean to always bring general relativity into the construct, but yes, I mean that's just maybe another way to see it, because if you have the double train problem, or even I mean, because if we're talking about a constant in if we're talking about a constant in this equation, you could just say every time a bigger person throws a bigger object at a smaller person with a smaller object, uh, the bigger person with the bigger object is going to always have more force. Now, is that a law of momentum? I can't say for sure. Is the bigger person always going to have the momentum? As in, is Earth always going to have the momentum since it's being thrown or hurled by? It's being hurled by. It's being hurled by the sun. So, in terms of the moon hitting the Earth, uh, it's the smaller brick is just going to not have any momentum. And so with the bowling balls, it's just bowling balls. You throw one, uh, you throw the smaller bowling ball, it has more velocity. You throw the bigger bowling ball, um, less speed. I'm just saying there's a greater velocity. There's a greater velocity in uh, the smaller object, but since it is an intuitive math problem, it's not a elementary problem. It's at the very least at the very least algebraic or calculus for force. Yeah, I mean, I can understand how the math works. Um, but just if you're two people where your constant variable, you always had a bigger person, you always had a smaller person. Um, is this like some proof of inverse square law? is this some proof of a a gravity? Because yeah, I mean, just if the math can be equated as such. But anyway, I mean, you could imagine the brick would just the brick wouldn't it wouldn't like fly back into the stands or something. If the guy throws a brick and it hits the cinder block, it's gonna uh, collide and it's gonna just kind of like tumble down. And obviously, I mean this brick is way it's 10 times, not 2 times. It's not twice as big. It's like 10 times bigger, but so it's something like that. Or if this guy was a midget and he was throwing the brick and it was going to hit this thing, you could imagine that the brick, if he throws it this uh, actual size, the brick's not going to go too far, and the brick's not going to go too far, and the cylinder block's not going to go too far. But the cylinder block is definitely going to go further in terms of a collision. So that's pretty much all I can intuitively come up with.